Hello everyone. In this video, we will learn about input and output in Rust. First, we create a file called input.rs for the code. The first line of code use stdio that we write is used to enable the input function in Rust. Then we create a mutable variable that can store a string from the input to be processed later. For the first input, we try using an integer. Then we print a prompt to request an integer input from the user. We create the code for integer input in Rust. Here it may look long and complex for a simple integer input. In this code, we request a line of string from stdin to then be stored in the mutable variable input. Then, expect is needed to handle errors that might occur when taking input from stdin along with the message to be displayed to the user. Next, we create a variable, number, to store the processed integer with data type, i32. We create the variable, then trim the input to remove whitespace including tabs at the beginning and end of the string. Then the string is parsed to be converted into an integer, and expect is used to handle any errors when converting the string to an integer. Then we print the variable to see the result. Let's open the terminal, then compile and run the program. Here the program requests input. We enter 4, 5, 6. Yes, the output is correct and there is no error. Next, we try decimal number input. We simply copy the integer input code as it is not much different. We just adjust the code for decimal number input, such as the expect error message. Also, change the variable name and use the data type f64. Don't forget to also print the decimal number. Try to compile and run the program. We input the integer 90 and the decimal number 12.34. An error occurs when processing the decimal number. This is because we use the same input variable for the decimal number input. Let's check what's actually in the input variable by printing it so we know the cause of the error with the decimal number. Compile and run the program. For the integer input, enter 90. We can see the content of the input variable is the string 90. Then we enter the decimal number. An error appears here. We can see that the input being processed for the decimal number still contains the string from the previous integer input process. This is what causes the string to decimal conversion to fail, while integer conversion doesn't. To fix this is quite easy. We can create another variable for input or use the existing one but clear its contents. Here we use the clear method on the input so that the string becomes empty before being used for the next input. Let's try to compile and run the program. The program runs without error, and you can see the string variable is correct without leftover input from before since it has been cleared beforehand. We just delete the input printing code. Next, we try boolean type input. Just copy the code as it's only slightly different from the decimal number input. Then adjust the input message and the expect error message. For boolean input, it's either true or false. Let's try to compile and run the program. Okay, the program runs without issues. Next is input for a character. Again, copy the previous input code since it is not much different. Then adjust the input message and the expect error message. Now, this is a bit tricky. A string is a collection of characters. Instead of using parse to get a single character from a string, we need to use the chars method to make it an iterator of characters. Then the next method is used to take the first character of the input string. We adjust the expect error message and don't forget to print the character. Then compile and run the program. Okay, the program output is correct without issues. Just remember the difference when processing string input into a character is a bit different as we don't use parse, but chars and next. Next is input for a string. Again, copy the previous input code. Change the variable name as well. Then the data type can be omitted because the input result is a string, so the data type is inferred automatically. For a string, parsing is not needed, so it can be removed. Also, expect can be removed since we are not parsing the string, so no error will appear. The trim can be left to remove spaces at the beginning and end of the string. Don't forget to print the string. Then let's compile and run the program. Okay, the string appears and the program runs without error. That's all for input of primitive data types in Rust. We have created string variables for input, then created inputs and processed them for integer, decimal number, boolean, character, and string. Next, let's just commit the code and push it to the GitHub repository. Okay, now we will discuss output in Rust. Let's create a file called output.rs for the code. First, we will discuss output using println. Println is actually a macro, not a function. Macros in Rust allow metaprogramming, which is writing code that writes code. Println will print a string while automatically appending a new line character at the end of the string. Here we will create a string variable, name, and an integer, age, that will be used in the code. The println macro can be used to print strings and variables. To print variables, they can be inserted into the string using curly braces. There are several ways to use the curly braces. The first is with plain curly braces. This will insert the variables provided as arguments to the macro in order. The name variable in the first curly braces, and the age variable in the second. Let's just try to compile and run the program. Okay, the result is as expected. The variables name and age are successfully printed within the string. Next is curly braces using the index of the arguments. Index starts from 0. In the code made, the first argument is the name variable and the second is the age variable. The name variable has index 0 and the age variable has index 1. So when processed by println, the curly braces will be filled with variables according to the argument index. Next we compile and run the program. Here the output is as expected because it uses the index of the arguments, not the order like the previous println macro. Then there is also a way to print variables using their variable names directly in the curly braces. Like in this code that directly inserts the name and age variables into the string based on the variable names in the curly braces. We compile and run the program. Yes, the printed string result is correct as we wanted. Then there is also a way to print by giving names to the arguments in the curly braces. Here we use the argument name, ABC, for the variable name, and argument, XYZ, for the variable age. The variables will be inserted into the string based on the argument names in the curly braces. Compile and run the program. The output is as expected based on the contents of the variables provided to the arguments. The next macro is print. This macro is similar to println, except it does not automatically append a newline character at the end of the string. In this code, we create two print macros. The output printed will be in a single line even though we use two print macros. This is because it doesn't append a newline character automatically at the end of the string. Here I added a newline character at the end of the string in the second print macro to flush the string to the terminal, although this is not guaranteed in all terminals. To flush, use iostdout_flush from the stdio module. Compile and run the program. Here the output appears in one line. The print macro is the same as println in the use of curly braces for string formatting, which is inserting variable values into the string. Since it is the same, I won't repeat the examples. Next is the eprint and eprintln macros, which are used to provide output to stdr, not stdout like usual output. The difference between these two macros lies in whether a newline character is added at the end of the string. Here I only give an example using the eprintln macro. This macro is used when you want to display errors, warnings, or debug logs to stdr. Compile and run the program. If run in a terminal, the output may look the same. But if we redirect the output of stdout and stdr to different files, the difference becomes clear. You can use redirection when running the program in the terminal. Next is the format macro. Sometimes you want to format a string or insert variables into a string without printing it to the terminal. That's where the format macro comes in. I created a variable, formatted string, that will store the formatted string by inserting the name variable into it without printing to the terminal. Then we print the formatted string variable to see its content. As you can see, in the println macro, we only pass the formatted string to be printed, because the formatting was already done earlier. Try compiling and running the program. The result appears as formatted. Then why can't the println macro print the variable directly without using curly braces, even though we already formatted it before? This is because the println macro takes a format string as the first argument, and it must be a string literal, not a variable. That explains why we cannot use println formatted string directly. Okay, we've learned about output using the println and print macros, then printing to stdr with eprintln. We also learned various ways to format strings, both printed directly and not. Next, commit the code and push it to the GitHub repository. That's all for the output material in Rust. The exercise program is a simple calculator. This program only takes two decimal number inputs, A and B. Then it outputs the result for addition, subtraction, multiplication, division, and modulus for A and B. Ignore errors that may occur if b is 0 during division or modulus operations. Please try creating the program without watching this video. If you've successfully made it, continue watching the video to see the solution. For the solution to this program, I will create a file, calc.rs. Then I use the stdio module. Then create an input variable to store the input string. Then I create two decimal variables, namely variable a and variable b. After the string is input, it is processed into decimal numbers. Don't forget to use expect to handle errors. Then we output each arithmetic operation result, addition, subtraction, multiplication, division, and modulus for variable a and variable b. Okay, that's all for the solution to the program. Now let's commit and push the code to the GitHub repository. Don't forget to like, subscribe, and share this video. See you.